talks about a representation, which raises all kinds of interesting philosophical questions. If these numbers are representations of something, right? Even though they're an infinite number of digits, then you come across the interesting question: well, a representation of what? Right? You can see why Cantor's colleagues, his mathematical colleagues, raised all kinds of hell and flack, criticism of Cantor when he came out with his papers, because it's deep stuff, deep metaphysical stuff, meta-mathematical metaphysics, if you like, right? So so the usual way, without getting too philosophical, is a real number is just a decimal number with an infinite number of decimal digits to the right of the decimal point. Let's define it that way. Okay? So the set of all such numbers is, by definition, is R. Okay. Right. So here's the theorem statement, between quotes as usual. R, big R, set of real numbers, is uncountable. In other words, you cannot form a bijection between big R and big N. Okay? Before, with Q, you could form a bijection between Q and N, but you cannot form a bijection between R and N. Okay? So this board and next, and halfway through the following session. So let's see, we've got 1, 2, 3. Yeah, we have four squares, put it that way. 1, 2, 3, yeah, four squares. So 2 sessions equivalent, proving this theorem. So put on your thinking caps. Okay, so you're asked to prove this. How would you go about doing that? So how do you prove that some set, whatever it is, in this case big R, set of reals, all the reals, how do you prove that it's uncountable? So in other words, you have to show there's no correspondence. In other words, there's no bijection, okay, that exists between N and R. Well, I was saying that a bit earlier. Well, the proof's going to be by contradiction. Okay, so we're going to assume there is a bijection between these two, and we'll start with that, and then we will deduce a contradiction. We will deduce some result which is the opposite of what we know to be true. Okay, so we get a contradiction, and therefore the original assumption that this is countable, that big R is countable, therefore that must be false. Okay, so classic proof by contradiction that we've done many times. Okay, so as usual, the proof by contradiction, you assume the opposite of what you're trying to prove. We're trying to prove that R is uncountable, so the opposite of that is obviously that R is countable. In other words, there is a bijection between N and R, big N and big R. Okay, so that means there's a function, a bijective function, that maps every positive integer to a real number. Okay? That maps big N to big R. In other words, right? That's if we assume the opposite of that, we assume this exists. All right. So we conclude, wrong word. We deduce that there is a function f. That's the function f here. That maps positive integers into a real number, or maps big N to big R. Right? Now, the contradiction that we're going to find is that this function f doesn't work quite the way it's supposed to. Something goes wrong. In other words, we will show we will show the contradiction that we're aiming at is that we will show the existence of a real number that is not mapped to. Right? In other words, there's no positive integer. So there's no member of big N that is mapped to this this real that we're going to find. Let's call it x. So we're going to construct a real number x that is not mapped to. Now, so what that means is, and now this number x that we're going to build is a member of R, okay, but it's not mapped to. Therefore, this mapping F is it is not onto. Remember the definition of onto? That means all members of your second set have an arrow to them from members of your first set. There are no what's the word? Straggler. There are no isolated members of your second set. So if we can find an x that belongs to the reals that is not mapped to by n, therefore this mapping is not onto, and therefore it is not bijective, and therefore, well, it's not a correspondence. Okay, but the assumption is that f is a correspondence, to use Sipps's term, or that f is bijective, same thing. Okay, you follow the logic? So now typically with to prove a theorem false, all you have to do is find one counterexample. So that's our strategy. We're going to find a counterexample. We're going to find a real number, x, capital X, that belongs to this, that is not mapped to by any positive integer. Therefore, this relationship, this mapping, this function, this f, is not onto, and therefore it is not bijective, which contradicts the assumption. Okay, so the proof now boils down to finding this x, and it was the genius of Cantor. He dreamt up a way to do this, and surprise, surprise, it uses the diagonalization method. So be in the next session how to do that. But I hope it's clear the strategy that we're going to use. Okay, now let me just see. Yeah. So verbally I've done all this stuff here. Oh, by the way, well, two things, by the way. Besides the damn flu virus, look, it's the date today. It is the 3rd of November. So even in Xiamen, the city where I live, the weather is finally cooling. So I'm out of shorts. You can't see it. What was I? Okay. No, I'm now in long pants and a sweater of a sort. Okay, so the weather. And there was another thing I was going to say. I can't remember. It'll come back to me. Right, so I'll stop there and go straight on the next session. It just occurred to me what the second thing was, so I won't stop. For the past 2 evenings, I have been going through all the videos, all of them, nearly 1,000 of them, which is amazing. In fact, I'll probably celebrate when I go over, when I upload the 1,000th video clip to YouTube. I'm getting close, very close, 950 something. I went through all of them. Well, not all of them. I just I looked at the first session of each letter, like each session, like 1 or 2 squares of the session, and they'd be split into parts, typically 2 or 3 parts. And I'd look at the first part, and just before during the time when I moved from switching on the camera to walking in front of the board, I would freeze the image so that I could see the complete board. And if there was some kind of title or topic heading or something, I put that heading on the right hand side of the link on my website. So now you don't have a unending, anonymous, informationless list of links. Now you have the chapter title, you know that, but there may be about sometimes 50 of these links, just one after the other. Not very helpful. So now there's lots of comments or topic or subtopic headings to the right hand side of the link. So that should help things a bit as you use my website to clicking on one link after the other. So you can jump around a bit and you know where you're going because of the topic headings. So I did that the last couple of days.